and cylinders. Help me shade in the region first before I do the working. I'm looking at this particular region and this particular region here. I'm going to rotate these two regions. This part let's do with respect to the y-axis. I focus on formula, the one for cones and cylinders. Unfortunately for cones and cylinders, if you're going to use formula, draw the visualization. We'll draw out together, then you will know what I mean. So let's rotate the y-axis, this vertical line here. Draw in the mirror image. This is what I will always do. If you're rotating y-axis, draw the mirror image first. Then you just connect the ends with this kind of oval shapes. You will be able to get a nice 3D solid. This is a cylinder. Label in. The reason why you visualize is to put in the height and also the radius. So cylinder formula, pi r² height. So pi 1² height. Next one, draw the mirror image. Endpoint at the bottom, put in the oval shapes. This is a cone. Cone, this is your radius. Label in the radius. It's just to avoid mistake, and also the height. Radius height of cone. What's the cone formula again? We are going for 1/3 pi r² times height. So we simplify the formula, 1/3 pi/8² times height. So the next question will then be, then you can integrate. Why should you try to use formula when you even need to draw? So when should you use which formula? If you are using formula, it's usually because GC not allowed. That will be my personal preference of how I decide whether I use formula or I can integrate. Because if you don't have GC, it may not be easy to integrate the terms and to submit the limits. Okay, but if you have GC, just use graphing calculator to integrate. No need to go and visualize. It's a waste of time because you can press GC for the whole integration. Okay, so that's how I will decide whether you can integrate or you use formula.